WebDriverWait is a class in Selenium that allows our test script to be dynamic. The test script can wait for a specified time before throwing an exception or wait for the element to be ready for an action. In the previous session, I mentioned I prefer not to use implicit waits on my projects. I do not use implicit wait because it is a global wait strategy that applies to all elements. It is best to apply a unique wait strategy to each element. So, by the end of this session, you will learn about explicit wait and fluent wait. Both wait statements are unique timing strategies that can be applied to each element. Let me start with explicit wait. Explicit wait pauses execution until time has expired or an expected condition has been met. We implement explicit wait statements using the WebDriverWait class. Now, let me go to the AUT by LambdaTest. The page is Bootstrap Download Progress Demo. The test script will click Start Download, then wait until 100% shows up. Let me copy the URL, then go to the IDE. In the IDE, let's start by creating our class. Right-click JUnit 5 test package, new Java class. The name is Dynamic Wait Test. In this class, we begin with WebDriverDriver. I'm going to import WebDriver. After importing WebDriver, we start with the configuration annotation before each, and it's going to execute before each test method. Public void setup test. That's why it executes before each test method, because it is a setup method. In this method, I'm going to write driver equals new Chrome driver. I'm going to also maximize the browser with driver.manage.window maximize. Bingo. After maximize, let's go ahead and load the AUT with driver.get, then paste the URL. Now, let's create the tear down method with the configuration annotation after each. Public void tear down test. And the statement is driver.quit, which quits the browser and the test. It closes the browser and quits the driver. Now, for our first test method, at test, the method signature is public void explicit wait test. Yes, now let's go back to the browser and inspect the elements. And I'm going to start with the download button. Right click, inspect. Make this a little bigger. And we see the element has a button tag with an ID value of DWN capital B TN. Okay, so we found that element. Next is to inspect 100%, because that's what we would verify when the test ends. 100% has a P tag name and it has a class attribute. Let's scroll up to the ancestor and look for an ID value. The ID value at the top is a div tag and it has 2 underscores next as the value. At this point, let's verify that we can find the value. And I'm going to write 2 forward slashes div and we see one of 250 elements. I'm going to write 2 square brackets at ID equals 2 single quotes next. Now it's 1 of 1. Let's go down and make sure we find the element for 100%. That was p tag, 2 square brackets. Let's locate it by using text. And it was 100%. Bingo, we found it. Copy the value. Now I'm going back to the IDE. The first step was to click the Start Download button. We do that by writing driver.findElement. We found it by the ID, and the ID value was 𝐷WN_BTN. And buttons we click. For 100%, let's write by complete 100% equals by XPath is how we found that value. And I'm going to paste the value. After the download is complete, the string expected message is 100%. We get the string actual message first by locating the element driver.findElement complete 100%. Then get a value from the AUT with get text. Now, the steps we have so far is clicking the button. We have the value for complete 100%, and we're getting the text back 100%, which is the message. Now we verify the value is correct by writing assertions.assert equals. And we're going to verify the expected and actual messages match. Expected message, actual message. And I'm going to write a message of expected and actual messages do not match. And it will only show this message if the test script fails at the assertion point. If it fails before then, it is going to be a failure. Let's run. Now, as a warning, it should fail, but not at the assertion point. It's going to fail with the no such element exception, and I will show you why. Bingo. We see it failed, and no such element exception is the reason why it failed. Let me scroll over. And we see XPath with the location of the 100%. It failed because it could not find 100% because our test script did not wait. At this point, we implement Explicit Wait, which requires us to use the WebDriverWait class after the complete 100%. And let me fix this message. I did not realize at first that I spelled it incorrectly. Expected message. There it is. I think that's right. Bingo. Now, WebDriverWait is what we use, which is a class. Wait equals new WebDriverWait. I'm going to pass in the driver. Duration of seconds, how about 10 seconds? This statement says our test script will wait up to 10 seconds or wait until an expected condition. There are many conditions we can wait for. If I cycle through the IntelliSense, we see many expected conditions we can wait for. But let's wait for the text to be, the parameters are by locator and a string value. The by locator is the complete 100%. We're going to wait for that complete 100% to be a string of 100%. Bingo. Now, we are going to execute, and this time it should pass because we're waiting for that message of 100% or that value 100%. Bingo, we see explicit wait test because it passed. Bingo, that's it. Okay, so at this point, we are finished with explicit wait. Next is fluent wait. In the IDE, I'm going to show you fluent wait after hovering the WebDriverWait class and clicking the class. And we see WebDriverWait extends Fluent Wait. Yes, and Fluent Wait implements wait. Now, since it extends Fluent Wait, and we know that Explicit Wait uses WebDriverWait, the difference between Explicit Wait and Fluent Wait is Fluent Wait allows us to wait for an element, check for the presence of the element, and also it lets us to ignore exceptions. So we can customize the Fluent Wait statement. For our test script, let's copy explicit wait and paste. I'm going to also change the name from explicit to fluent. Bingo. Now, after this point, we start below the 100%, and I'm going to remove the WebDriverWait. And we start Fluent Wait by writing, we can write wait equals new Fluent Wait, and implement or import wait. And we also have to import Fluent Wait. Now, since we saw Fluent Wait implements wait, we can also change wait right here to Fluent Wait. My typing. Either way is okay if we write Fluent Wait or wait. Next, I'm going to pass in the driver. Now, the next statement will wait 10 seconds for the element to be present. Now, we wait for the element to be present. Let me also fix this. Even though it's minor, I'll just we wait for the element to be present by writing dot with timeout, duration of seconds, and I'm going to write 10 seconds. This means the test script will wait 10 seconds for the condition to be true. And it's going to poll every 1,000 milliseconds by writing dot polling every, duration of millis, and pass in 1,000. The polling every method indicates our test script will check to see if the statement is present every 1 second, and 1 second is equal to 1,000 milliseconds. The last part, ignore one or more exceptions. And we ignore exceptions by writing dot ignoring. Bingo. Our first test, when it did not wait, returned a no such element exception. So we can write in no such element exception for our test script to ignore that exception. That's the beauty of having this customized way to write our dynamic wait statement for Fluent Wait. Since it could not find that no such element exception, it's going to ignore that, and we must always add dot class at the end. And since we can't ignore one or more exceptions, let me go ahead and write one more exception to ignore. How about we include dot ignoring element click intercepted exception dot class. That's going to be the second element we're going to ignore. And we can add more exceptions if we want to. Now, the next statement is to wait until an expected condition. And that expected condition, for explicit wait, we use text to be. However, a lot of times people use visibility of element located. And for visibility of element located, I'm going to pass in a bilocator. And we know the bilocator is complete 100%. So let me pass in the complete 100% locator. And at that point, I will add the semicolon. Now, let's run the Fluent Wait test. Go up, and I have to make sure I have the @test method for Fluent Wait. I have it for Explicit Wait, but I did not copy, I guess, for Fluent Wait. Now we see the green arrow to execute. The run window should show a green check mark because it should pass. 100%? Yes, green check mark because the test waited. You know what? Let me run this test one more time with both methods. I'm gonna run both methods at the same time as a class. And just to kind of see a difference, I'm gonna make this Fluent Wait test fail by removing this %sign. And scroll up and run the class. So both test methods execute. There's one test, explicit wait, it passed. And this one should fail with a yellow icon. Yes, bingo. Fluent Wait test failed with a yellow icon. And we see the message says expected and actual messages do not match. Expected shows 100 and actual shows 100% with the %sign. That's why it failed. Okay, cool. So we are finished with WebDriverWait. Next is minimize browsers. If you would like to learn more, then make sure to follow the blogs at www.LambdaTest.com/blog and community.LambdaTest.com. In addition to the blogs, you can earn a certification at www.LambdaTest.com/certification. Get educated, get recognized.